All right, so today's notes are on polynomial functions. Our content objective is to classify polynomials, graph polynomials, and describe their end behavior. Our language objective is to use the correct terminology to describe and classify polynomials and their end behavior. So we just finished up our quadratics unit. So we were working specifically with quadratic polynomials. So polynomials where the highest degree was 2, or the highest exponent was 2. Now we're going to start working with larger degrees, or polynomials that have higher exponents. So cubic functions, quartic functions, quintic functions, and that sort of thing. So to delve into this unit, we're going to start with some key vocabulary. So the first term, we probably have used this before, but monomial is a real number, variable, or product of a real number and one or more variables with whole number exponents. So more or less a single term would be a monomial. So a term where there's would be a monomial. The degree of a monomial if there's only one variable. So this is if there's x and y in your term, then this is no longer true. But if you have a monomial with one variable, it's the exponent of the variable. So if you're talking about x squared, the degree would be 2. X to the 5th, it'd be 5. Or the degree would be 5. So that was what we mean when we talk about the degree of a polynomial. Or a monomial, sorry. A polynomial is a monomial or sum of monomials. So this is when you start to get more than one term. So if you have like x squared plus x, now you have 2 monomials, so that will bring you into a polynomial, or make it a polynomial. Technically, a monomial is a polynomial as well. It's just when there's one or more terms. A degree of a polynomial, again, this is only true when there's one variable, so x or y, but not both. This is the greatest degree among its monomial terms, so that's why quadratics, we're referring to the highest degree, so x squared, that's the degree of that polynomial is 2. So if you have a quadratic function, the degree of the polynomial is 2. If you have a cubic function, the degree would be 3, so on and so forth. Standard form of a polynomial just arranges the term by degree in descending numerical order. So here's an example. We go 5, 4, 3, 2, 1, none. That's standard form of a quintic function. So again, it just arranges the variable with the exponent with the highest degree first, the lowest degree last, and that's how we set up standard form of a polynomial. So this is sort of the intro to the correct terminology that we'll be using throughout this unit. The next table also delves into that with some more specific examples so you can understand what I'm talking about. So a degree of 0, so that means when I refer again to a degree, I'm talking about the exponent. So if you have a degree of 0, that's just a constant function or a constant. So 5 would be an example. There's no variable, or the variable would have an exponent of 0, which just makes it 1. There's only one term in this example that I gave, coincidentally, not inherently because it's so, but there's only one term, so it would be a constant monomial if we were describing this term, a constant monomial. If we had a degree of 1, that means our variable only has an exponent of 1, so we don't write an exponent of 1, so we just have x plus 4. This is a linear expression, so we have a linear expression. There are 2 terms here, so we have the x and the 4. Those are 2 separate terms, so we call it a binomial. Again, we've talked about constants, we've talked about binomials, we've talked about quadratics. So quadratics is when you have a degree of 2. So when you have a degree of 2, you call it a quadratic. This is an example of a quadratic, so we have x squared. But since there's only one term here, it's a quadratic monomial. So because it's just 3x squared, that's one term. It's a quadratic monomial. That's how I describe that example. Cubic, we have a degree of 3. So if you have a degree of 3, it's a cubic expression. And in this example, I have 3 terms, so it would be a trinomial. So I have a cubic trinomial here as my next example. And then the next one I have is a degree of 4. It's a quartic function. So I have x to the 4th minus 2. So we describe that as a quartic binomial. So there's 2 terms, but it's to the 4th power, so it's a quartic binomial. And our last one is a quintic function. So it's a degree of 5. We have 2x to the 5th. Sorry, this is squeezed right in there, but 2x to the 5th plus 5x cubed plus x minus 2. There are 1, 2, 3, 4 terms. So once we get past trinomial, we just describe it by polynomial of 4 terms, polynomial of 5 terms. So it's a quintic polynomial of 4 terms, this last example we have here. All right, so I'm going to flip the page and go on to a quick check for this. So we're going to practice classifying our expressions by degree and number of terms. So classify these polynomials by the degree and the number of terms here. Pause if you need to, try it on your own. I'm going to go over it now. So my degree here is 4, and there are 4 terms. So I would describe this as a quartic polynomial of 4 terms. So because there are 4 terms, my degree is 4. It's a quartic polynomial of 4 terms. If I look at this one, my degree is 3. So it's going to be a cubic polynomial. So the degree is 3, so it's cubic, but there's only 2 terms, so it's a cubic binomial. So our second example is a cubic binomial. All right, so the next thing I want to talk about is the degree of a function. So the degree of a function affects the shape of the graph. So again, we've talked about, obviously, quadratic, cubic, quartic functions aren't going to have the same shape or the same general shape. So the degree of our function is going to affect the shape of the graph. It's also going to specifically affect the maximum number of turning points, or which are relative maximums or minimums. So we can only have as many turning points as we have, or one less than the number than the degree. So if it's cubic, you're only going to have 2 turning points or maximums or minimum. If it's quadratic, you only have 1, linear, none. But the number of turning points is determined by the degree of your function. The roots, zeros, or solutions, or x-intercepts also is affected by it. So the number of possible x-intercepts is determined by the degree as well. So if it's to the 4th power, there are 4 possible roots, zeros, or x-intercepts. If it's cubic, there would be 3 possible root zeros or x-intercepts solutions. And then last but not least, we have end behavior, which we're going to delve into today. This is the one other big concept that we're going to be focusing on today outside of vocabulary. So we'll talk about all these different things throughout the unit, including end behavior, but end behavior and vocabulary is going to be our focus for this section today. So for end behavior, that's the directions of the graph for the far right, or far left and far right. So it's what the graph is doing when you look all the way to the left and all the way to the right. So in this first example, we have a quartic function. So we have 4x. This is a rough sketch, so it's not precise, but general shape. 4x to the 4th plus 6x cubed minus x. And what I'm looking at is what's happening at the arrows at the end. So where are the arrows going on the end? So for my end behavior for this, behavior, that's an R, sorry, end behavior. For my end behavior, what is the left side doing as I look at it? It's going up. So the left side goes up. I'll describe it that way. And then the right side is also going up. So my end behavior would be up and up. So it's increasing on both ends of my graph. So my end behavior is up and up. If I look at the next one, this time we have a cubic function, or cubic polynomial, or cubic monomial, I should say. Our end behavior here, if I look at the left side, it's actually going down this time. So my end behavior would be down on the left and up on the right. So it's down and up for my end behavior for that example. I'm going to flip the page again. So for the next one, I have a quadratic. This time it's negative, so again, it's a rough sketch. So my end behavior will be down and down. Last but not least, I have my cubic. Again, it's slightly different this time. So my end behavior, it's another cubic function, but this time the left side goes up and the right side goes down. So it'll be up and down for my end behavior. So the sort of trends I want you to notice here is that when we have an even degree, it's going to, so this is going to be one of our key points. If the degree is even, then the end behavior is the same on both sides. So it's the same on the right and left if the degree is even. So again, our quartic and our quadratics were the same. They're both up, up, or down, down. So if your degree is even, it's going to be the same on the left and right. You may have noticed that the opposite is true if the degree is odd. So if the degree is odd, then the end behavior goes in opposite directions. So then the end behavior goes in opposite directions. This is so if we figure out if it's going to be the same or both, we just look at the degree. So if we want to see if our end behavior is the same on both sides or opposites, we just see is it an even or odd degree. That's easy enough. The other thing we need to pay attention to, as you may have noticed with the cubic functions or quadratic and quartic, is whether they're going up or down on which side. So the way you determine if it should go like up, down, or down, up, or down, down, up, up, is by looking at the leading coefficient. So if A, which is the leading coefficient, or the coefficient of the variable in front and when it's in standard form, so the coefficient of the highest degree. So A is the coefficient of the highest degree. So if the leading coefficient is positive, then the right side goes up. So if the leading coefficient is positive, the right side goes up. So we're going to end with some quick checks really fast, and then we'll be done for today. I want you to determine the end behavior of the following polynomial functions. Our first one is f of x equals 3x to the 5th minus 4x squared plus 1. And our second one is going to be negative 2x squared plus 1. So pause it, try it on your own right now. I'm going to go over it. So I'm going to abbreviate end behavior to EB for the moment. But our end behavior, first thing I'm going to notice, the degree is odd. So that means they're going to be opposite. So it's either going to be up, up, or down, down. So then I'm going to look at the leading coefficient. So A is positive because my 3x to the 5th is the highest degree. The coefficient of x to the 5th is 3. So it's going to be positive, which means the right goes up. So I know my end behavior is going to be up on the right side. Since it's opposite, I know that the left side must be down. So it'd be down, up for my end behavior. Sorry, I cut that off. But my end behavior will be down, up because the right side goes up, which means, and since they're opposites, the left side would have to go down. So now I'm going to do this one. So again, end behavior, the degree is even. So that means it's the same. So the degree is even, so it's the same on both sides. My A value this time is negative, which means the right side goes down. So the right side of the graph is going to go down. So my end behavior here, I know the right side goes down. It's going to be the same on the left, so the other side must be down as well. My end behavior is down, down. So I have down, up for the first one, down, down for the second, and that's all for now. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.